Hi everybody, this is Andrei, and in this video we continue the tutorial sessions for the Luma-mu. And this one is quite unusual because I'm going to explain how to use the Luma-mu in the Wavetable oscillator mode. And just to remind you, if you haven't watched the original overview of this, it's a special mode that allows to play the sounds on the EEPROM continuously. So there are 8 sounds, and in a drum mode is just a one-shot playing. In the loop mode that you can use with the wavetables, it will be always playing, never stopping. And in order to do that, there is a jumper that's on the back that you have to remove, and so then in that mode it doesn't stop. So that also means that as soon as you power down the module, it starts playing like the oscillator. And so you have to control it externally, of course, VCAs or something else, or filters and so on and so forth. We will take a look on that as well. It has the dynamics input that can technically make a VCA out of that. So I will show you how that's all working. All right, so we will move to my setup here. I have a mini skiff with 3 modules installed, and I have the products here on the left by Expert Slippers. Why I have it? Because this is what we will be using for the CV interfacing from my computer. And so, since the module wasn't designed as the oscillator originally, it's the extra capability that you can use it for, and of course the LM1 drum machine has never been designed in a way to be used with the CV controller oscillator. So what I'm trying to say that the pitch input, it's not linear. It's not volts per octave, it's not volts per hertz. It's something on its own that requires the external calibration to make it linear, to make it consistent with the tuning tables. And the Expert Slippers, well, they have a steep learning curve, honestly, but they allow you to do the automatic calibration and automatic tuning. And I'm using the setup here that's based around the Expert Slippers ES40 module, which has the single stereo digital input over SPDIF. And I run it with my mobile audio interface by Antelope. It's a Zengo. And that's why I have the independent SPDIF out connected to this module, and I can still use the analog outputs as my primary outputs for this. There are different ways to scan a cat, and there are different products by Expert Slippers, including the ADAT based with a light pipe connection, including the USB connection, and including some of their later products, one called Factorum, which is a standalone ear rack module which has a capability to build the tuning tables inside the ear rack, and I will do a review of this module later. So in this setup, quite complex setup, honestly, we will focus how you can basically operate with Luma-mu in the wavetable mode and what exactly you can do with this. Okay, so, you will also see that I have something else connected that is quite unusual, so we will be using this module only. It has the reach around extender connected, and it has the EEPROM, and the EEPROM called All Signs. You can download this EEPROM for free. It's on GitHub. I'll post the link. And you can program it to your own EEPROM, or you can program it to the Picorom and use it later. What it has inside, it has the 8 sign wavetables with different harmonics, and this is what we will be using to build our wavetable oscillator here. So if I play this module, and it's currently silent because I stopped it, and the way I stopped it with this small keychain product that we did as a giveaways for NAMM, and what it's doing basically, it's a battery powered gate sender. So if I connect it to the, let's say, to the pause input, because you can see it, if I press a button, LED is on, and the LED is on here, so basically it's sending the gate. And when the Luma-mu is triggered, and it's always oscillating, obviously, the only way to make it silent is to use the reset, and this is why I'll be using this, just to keep speaking and not start screaming on top of that. Okay, so if I start this EEPROM and just browse the sounds, so these are wavetables that we have here. And now let's take a look on my computer setup, how that's connected and routed to the expert slippers. Here, well, this is Ableton session. It's quite small. Basically, we only need two channels. One channel is a MIDI channel, another channel is the audio channel. And it has one plugin loaded here. It's called Element Effects. Element Effects, in fact, is the virtual patch bay that allows you to load inside it multiple plugins and connect it in any way you want, including the MIDI and audio. And the reason for that, because expert slippers are complex products. They come with a whole bunch of different plugins in the Silent Way package. It's a commercial package, so once you got hardware, you have to also activate the Silent Way. And in order to use it, you have to configure them and connect it in a specific way. If you look all the expert slippers videos, you will see that they do that typically through the just having a multiple tracks inside Ableton and audio feeding from one track to another track and having some tracks on a record, some of them on the monitor. Well, I found it complex, and honestly, once I have that set up, next time I forget it immediately what it's doing. So it's much easier to use the patch bay like this, because at least you can preserve this and you can save it as also a preset file. So in order to operate with the ES40, and that is specific to the ES40 module, I have to have the ES4 controller that basically is multiplexing all the inputs into this, so it has multiple inputs. And because I also have the two extension, one is just a gate extender and another is a CV extender, I have to run additional module that is EX8CV, that's for CV extender. So that's why only this part of the setup is already complex. But really what we need and what we'll focus the most is the plugin called Silent Way Voice Controller. This is all-in monophonic synth controller. So it produces the gate, CV for pitch, and the ADSRs for whatever you need, for VCAs and for VCFs and so on and so forth. It also has this built-in capability to do the tuning maps. I have to say, it's not always working. The way it uses, of course, it's, it needs clean sound and with less harmonics, and so there are lots of dependencies where it starts tuning and how exactly it tunes, but just overall, well, you can get it working, and also a way to save that calibration map back to the computer, so you don't need to do that every time. But with Luma-mu, most likely you want to do that all the time, because it doesn't have a thermal compensation for the CV input, so you might run out of tune. Okay, now if I also show you what other modules I have connected. I have two LFOs connected here, and they go to the last 4 channels of this 8-channel CV expander, and that's why you see them blinking, because they're in a free running and they just run a bunch of LFOs. One is running linear, another one is triangle, and the easiest way to demonstrate that I'm running it, the LFO, I can just link it to the, let's say, sample select. And you see that, this one is running in a triangle. I set these, the tuning, the potentiometer in the middle, so that sets exactly from the -5 to 5 volts, and this is what this CV expander is sending currently. All right. Now, you would ask me, what if I don't have expert slipper products, and what if I just connect the regular CV controller? What happens to the Luma-mu? Well, nothing happens. It will be just running out of tune. And to demonstrate that, I have the simple Arturia keyboard with a CV output, and I only have a CV for pitch. I connect it here, and I will trigger it and play several keys, and you will see what it's doing. So basically you have to have it in tune and you have to provide some map, otherwise this one is obviously not in tune with that. It scales, but it's not in tune. And we have to reduce the range and we have to adjust it. So to do that, I will connect first of all the pitch output, CV output for pitch to the pitch input here. And this is what I need for this setup. And now if I play same keyboard, which now just sends the MIDI data to the Ableton session, we can hear that it's running, how it's running. So I calibrated it with the previous settings, and the way you do the calibration, first of all, you have to feed back the output of this module into the in the audio interface, and that's why I have a splitter. So one channel goes to the camera, another one goes to the back to the interface, so it has a loop back and it can do the tuning. And then you create it to calibrate. You click it to the calibrate, and it starts a calibration. So in order to do the calibration, you have to run the oscillator running. So let's do it again. So you can see here that it's on my screen. It's calibrated it within the some window. And of course, the offset potentiometer position also matters here because it will set you to the central frequency where it can calibrate. And if I start playing it right now, so it will play within this range, calibrate it. So we can try. Okay, so that's a simple setup here. Now, what else we can do? Because the Silent Way voice controller can send also ADSRs, we can use another output of these and we can map it to the dynamics. And for us, dynamics will be, well, we will be using it as a full VCA. In fact, this can be called a VCA, just a very specific kind where you control the reference voltage on the DAC, but, well, this is VCA. So what's happening right now? In my Silent Way controller, I'm sending the another hardware output. This is here. That's coming from the envelope 1, and this envelope goes to the output 2, and by default it's in some negative stage, and then it creates the envelope and it goes back to its stage. And so I adjusted the voltage with that again with the potentiometer to set the reference where it wants to be, because if I put it too high, you will start hearing actually, so it won't go all the way down. So I have to put it down, so in a way then, well, the envelope goes back to the 0, and in that case in some negative value, well, it closes the VCA. And so then everything starts working magically. So you can also hear a pop, and that's basically a pop coming because I have no attack. I'm just opening it too quickly. Yep, so that's how it's working. I hope it's helpful, at least a little bit. In the next tutorial, we will take a look how to create waveforms, and it will be a lot of fun, honestly, because creating waveforms which are precisely aligned and fit into the EEPROM space is also a bit creative process, and there are multiple tools to do it. So stay tuned and watch the next video. And I hope that this one really helps you to understand what these extra capabilities Luma-mu can have outside of just being your drum channel, which certainly it is. Well, thank you. Thank you very much for watching. See you next time.